So we're going to get back into geek mode, and I'd like to call up ScaleArc for anyone interested in databases. They are a pioneer in a new category of database infrastructure software that simplifies the way database environments are deployed and managed. It also lowers the cost without any changes to applications or databases. So while they're setting up, this is actually my favorite part of every meetup. Aside from the demos, of course, I'd like to ask everyone to turn to their left or right and basically meet someone that you don't know before. Take a couple minutes to introduce yourselves, find out what to do, and meet someone new.
So the first thing I did before I came up here, I made sure I removed any BitTorrent software because I'm scared to Hey, thank you for allowing us the time. My name is Chris Little-Reyes. I'm from ScaleArc, and ScaleArc is a newer technology today that abstracts your database away from your application. And why is that important? Well, if you use databases or administrate databases or have some interactions with your applications today and see lag or not sure what's going on in the background, it's very challenging for DBAs to maintain a structural integrity of those data sets and to be able to offer them to your applications with that high performance and availability so that it's seamless to use the end user. So the company is based out of Santa Clara, California, and like I mentioned, it's an abstraction of your SQL database from your application, and it allows horizontal scaling of your infrastructure that's seamless to the application and you, the end user, providing high availability and better performance. And what's unique about ScaleArc is we're providing real-time instrumentation or real-time analytics at the transaction layer, right? So typically today, administrators and IT really have to look and analyze the data sets on the database service directly. Okay. And or from your application service, not really seeing anything inline. That's my boss. And so with ScaleArc being in line, being able to give you those analytics, it allows for intelligent decisions to be made on how your data is behaving without the dependencies of your systems or systems analytics on the database side or from the application itself or from the decoding application. This translates into lower cost, higher transparencies, and with the ScaleArc technology, no changes to your existing applications or databases, which means quick time to implementation. We currently support MySQL and SQL Server for Microsoft, and we're coming out with Oracle support by the end of the year. The platform is offered as an ISO, essentially, which can be applied to bare metal server system, applied to a VM hypervisor of your choice, and also be available as a cloud-based solution on systems like Amazon or GoGrid or any one of the cloud providers. It's built in with multi-tenancy support, so I'll show you some of that in the application demo itself. There's a few pricing models, and the development of the application has resulted in quite a few patents that are pending in the patent office. So the typical problem today is that your applications are built with one-to-one connection statements or one-to-one connections associations from the application to the database. So as your application grows, the sort of the connection statements and the relationships between your application and your database becomes very complex. So the challenge is really how do you manage that as your application and demand of your applications grow. And when you start scaling that out, how do you really readdress those issues and reapply them into your application logic? You start to get into trying to load balance the performance against multiple databases on the back end. Well, how do you really control that load balance across that infrastructure? it becomes very challenging. And in doing so, you really have to write it into the code itself. There's nothing agnostic, nothing abstracted away that allows this to be done without low-level coding development, whether it be in the application or the database side. And that also doesn't allow for any holistic or management of really what's going on. So you either have to look at it from the application server, from the database. So there's really no easy change. It's really complex to get around, and it's heavy CapEx, heavy OpEx to address the issue. With ScaleArc, we become inline to the application and the database. That means that everything conforms into a single line of traffic. So if you think about us as a protocol analyzer, for those of you familiar, or with an F5 or any type of load balance solution that's commonplace today, we're that type of technology, but specifically built for SQL transactions, SQL statements. This allows for connection pooling, multiplexing, getting away from that one-to-one model where your application will look at IDB or the ScaleArc solution as a single database resource and having multiple topology infrastructure for your SQL support on the back end. And this can be augmented at any time and scaled outward. Providing some read-write splitting, so a load balance solution allows for the distribution of that data to be spun out across multiple instances, again, being seen from the application as one instance, where the underlying topology is many, and controlling that topology when things change. So failover, your application changes, you want to bring a server down for maintenance, things of that nature, really become transparent to the application, high availability, and transparency to the app. Allows for instant horizontal scaling, sharding, multi-master support. I seem to be maybe losing some audience here, but simplified failover and protection, right? So it really means better uptime, better visibility, and with analytics, which is the next portion of the slide here, really gives you the visibility into making the decision. So we can see what's taking so long, where your bottlenecks are, and making decisions on that data without having to be a DBA, essentially. So let me show you some of the highlights here. So within the IDB interface, right, we see multiple lines of clusters. Clusters can be associated with applications, they can be associated with business units, or simply customers, right? So if you're a service provider, whether you're an IT organization that's serving out to your customers, we can sort of segment this data, maintain separation of integrity and separation of data itself, and provide insight into what that data and how that's performing across the network. I'm going to start to generate some traffic here so we can see exactly how. Okay, so I'm starting to see some traffic come through IDB, and what's interesting is, without any caching or any technology turned on in the back end of IDB, we can see how connections are starting to come in to the IDB appliance. And below, we can actually see how load is being distributed across two different servers. So immediately, we're getting distribution from a single or multiple instances of an application server pointing to IDB as a single instance, and distributing them across to two different servers. Below the live monitor specs is deduplication of log files. So not only are we seeing the performance of the SQL transactions themselves, but we're also seeing the real-time instrumentation of the log files deduplicated and from a single instance, from a single perspective, holistically from IDB. So this is all at the transaction level, independent of that of your database server, independent of that of the applications themselves. It's in line like the protocol analyzer itself. So as I move into analytics, analytics will give me a 4-quadrant graph to tell me how my SQL statements are performing across the network. And we put them into 4 categories: frequent transactions, frequent fast queries, infrequent fast queries, frequent slow queries, and infrequent slow queries. Basically, you're looking at different buckets of performance in these types of transactions. And by highlighting over any one of these balloons here, we're actually deduplicating and pulling out the variables. So I can get very quickly to a problem query statement that's taken quite a long time to complete its transaction against a database server. In essence, this is a transaction or a user clicking on a button, and it's taking too long for it to execute, and there could be a problem with that with the statement itself. So we can do 2 things. We can take this statement, give it to a developer, and say, "Hey, optimize this because it's taking too slow," or we can simply go and add this rule into cache. So instead of querying the database directly from the application, let's add this to IDB cache itself and let IDB respond out of memory. So this improves dramatic improvement in performance, almost 20x. It really, by serving this out of memory, IDB itself doesn't have to process any IOs. It doesn't have to process this query from the database. It has it in memory, can serve it in real time. We break down the query structure itself. I can get a sense of what the performance of the query itself has, how long it took, how many queries that particular statement took to run, the cache hit ratio, server time that it expended on the server itself, and the cache time it took to serve this query up as a result. Let me go back to the cluster configuration and show you some of the scaling capabilities. So we can take 2 database servers, one is a read-write, one is a read, and while traffic is moving across the wire, I can actually reconfigure these and switch them. I can either take one offline, I can bring a server online, I can switch it from read to read-write, and manipulate the structure that's supporting the cluster itself. All while data is passing through the IDB itself. So as we go back into the cluster performance, the live monitor, we should see data has now been switched, and with no or little impact to the application itself. So data has continuously been served up by IDB itself, but we can add in data. We can add or remove databases on the fly and switch them from read to read-write whenever we need to prepare. Great. Thank you.